Today we are going to go over questions 7 through 10 on Exam 2, Part 1. Question 7. Given water at 120 degrees Celsius with a specific enthalpy of 2,400 kilojoules over kilogram, what is the phase? We will first draw a pH plot along with our dome and labeled regions. We then draw our constant temperature slice, which is 120 degrees Celsius. Using table C1, we can locate HF and HG for water at a temperature of 120 degrees Celsius, HF being 503.7 kilojoules over kilogram and HG being 2,706.3 kilojoules over kilogram. Plotting our enthalpy value of 2,400 kilojoules over kilogram, which is between HF and HG, we can then locate where our H value intersects our temperature slice. It intersects under the dome, meaning our phase is a mixture of saturated liquid and saturated vapor. Question 8. 15 kilograms solid silver is heated from negative 40 degrees Celsius to 50 degrees Celsius at atmospheric pressure. Assuming that there is no change in the volume of the silver, what is the heat transfer in kilojoules for this process? The given information includes M equaling 15 kilograms. The difference in temperature can be determined by subtracting T1 from T2, which we find to be 90 degrees Celsius. We can use the equation Q equals delta U plus W, where Q is heat transfer, delta U represents energy, and W is work. Work is equal to 0 in this case due to the no change in the volume, making Q equal delta U, which can be rewritten as Q equals mCp times delta T. From table B4, we can find Cp, which is constant pressure specific heat for silver. We can then plug in all the values in our equation, calculating the heat transfer to be 314.55 kilojoules. Question 9. What is the change in specific internal energy in kilojoules over kilogram when the ideal gas air is heated from 480 Kelvin to 1,580 Kelvin? Use the most accurate method to calculate this answer. In order to determine the change in specific internal energy, we will have to find the values of specific internal energy at the two different temperatures, 480 Kelvin and 1,580 Kelvin. Using table E1 for the properties of air, the two values can be found. U1 being 344.7 kilojoules over kilogram, and U2 being 1,279.65 kilojoules over kilogram. Plugging the values into the equation, the change in specific internal energy is determined to be 934.95 kilojoules over kilogram. Question 10. What is the change in specific enthalpy in kilojoules over kilogram when the ideal gas carbon dioxide CO2 is heated from 440 Kelvin to 1,700 Kelvin? Use the most accurate method to calculate this answer. The change in specific enthalpy is equal to H2 minus H1. Using table E4 for properties of carbon dioxide, H1 and H2 can be determined by locating T1 and T2. H1 is 15,054 kilojoules over kilomole, and H2 is 82,856 kilojoules over kilomole. Plugging the values into the equation, the change in specific enthalpy is calculated to be 67,802 kilojoules over kilomole. Using table B2, the molecular mass for carbon dioxide can be used to convert delta H into kilojoules over kilogram. And when doing this, delta H is found to be 1,540.6 kilojoules over kilogram.